Okay, this is a opening picture just to get your attention here. This is the T-Lud that I made the earlier video on, giving you a full cycle on the burn on it. But on this picture here, this is the first burn we made. And the very tall flame is because we didn't have forced secondary air in there to burn it as efficiently as it should have been. Also, it's quite dark to make the flame show off quite well. So I got a hold of a 350-gallon propane tank and started chopping up on it. It weighed 1,000 pounds, so you have to wrestle it around a little bit. So I've chopped off the bottom to make the base and to install all the fans and controls and that sort of thing in it. What you're seeing there on the rim of it is part of some angle iron that I've chopped up and been around there. One angle iron for the welded onto the bottom piece and one onto the top piece, so I can bolt them together when I get it finished, and also take it apart when I have problems. At this point, I have the hearth installed. It's 1/8-inch stainless steel, which should be a bit more rugged because that is the one place that gets the hottest when at the end of the burn, because the charcoal starts burning and it gets quite hot. Here I'm making a cutout for where the unloading auger is going to be. You can't tip over a 350-gallon T-Lud and scrape the biochar out like we do on the smaller ones. So we have to put an auger on the bottom to unload it. Just working on it, laying it out as best I can, trying to get my head wrapped around the geometry of it. Here I have the part of the unloading auger welded into place there right now, and haven't got a top on it or anything. I'm using a square auger because I don't have a round tube, and also square stuff is a little easier to work with. And we have the two angle irons bolted together already, and we'll fit the top into there, wrestle the top into there, and then weld the top angle iron onto the top piece. Just another picture of it laying down here, and we're working on it. It goes fairly slow. Show some more details here of it welded together, tipped it back over. And have it setting back up again. Quite often tipping it back and forth, working on it all the time. And also shows here some duct work. A little square sitting out the right side down at the bottom is tubing that's going to duct the air into there, and I'll show you the fan on that later on. So now here I have a fan mounted on there, and I also have the drive for the auger mounted on there. I took pictures only randomly, so this is I don't have a very good documentation here, but the fan is 24 watts. It's a large computer fan for, like mainframe computers, something like that. That's the biggest consumer of energy on there, except for the auger motors, which are of course quite large. It probably burns 700 watts when it's running, but it only runs for a few minutes during a complete cycle. Here we have the base assembled, and we just couldn't resist doing a little test burn in it. It'd make a heck of a nice patio heater, wouldn't it?
There you go.
Well, it's sitting upright now, so we're continuing to work on it here. What I want you to notice now is that the pipe coming out of the top and running down into this other small barrel there through a nozzle is a very important part of the design of all T-Lods that I make. I want to be able to use all the heat that comes out of the T-Lod. Don't want anything to be wasted. And obviously it'd be pretty hard to get a heat exchanger up on top where we could maybe transfer that heat to a boiler to heat up hot water for heating a home or something. So we brought the pipe down to the bottom and through that nozzle there, and what we can do is we can put a heat exchanger down at ground level where you can maintain it. Another thing you can do with the gases coming down is you can run them through an internal combustion engine, and then you'll only extract about 20% of the heat at the most through an internal combustion engine that's maybe running a generator or powering some other thing, and the rejected heat that comes off from you'll have 80% of the heat left over that you can pull off from the water jacket and the exhaust gases and put that into a boiler for heating a greenhouse or maybe a cluster of homes or something like that. Well, it's finally standing upright. It's looking like we're getting pretty close to making a burn. We're quite excited about the work we've got done here. Here we have another picture here that shows the little computer fan that I have on there, and all of these. I don't have the control panel on yet, but or I do have the control panel on. I do see that control panel there. And it's got a variable, the fan is variable speed. Now, we had to start thinking about, how we're going to load it. And we weren't as nearly close to the burn as we thought. Here we rebuilding an auger that somebody gave us. And we'd ordered some new flighting for the auger, a new shaft, and ordered 6-inch flighting for our 6-inch auger. But let me give you a little hint. That's a mistake. When you have a 6-inch auger, you want some 5 1/4-inch flighting for it. So what we had to do is start practicing our slinky making skills and cut off about 3/8 of an inch all around that auger. So if you see that piece I cut off, I laid it out there. I thought it was a pretty spectacular view of a dumb mistake I'd made, but anyway, we got through that. So now you see it back on that first burn here, a little bit of video on that. And hope this is something that will help you out. It's an alternative to Adams retort or some of the farm size units that are out there, but it's I think it's a very good alternative because it's made so we can use all the heat. Now obviously I can't use the heat out here. I'm wasting the heat. The disadvantages for a T-Lod like this is that you have to have a fuel that you can run up the auger and get in there. Now, we use pecan shells. It works when we can get them. That's an excellent fuel. But you could also use chipped wood or anything else that you could feed up the auger and get into the unit. Hope this video helps you. If anybody works on this and does it in the spirit of the Creative Commons, like to stay in touch with you, and any improvements you make, I'd love to hear about them. And I will, if anybody's serious about building one of these themselves, I will try to respond to you eventually if you make some comments on the YouTube video. I'm not real good about that, but I'll do my best and try to stay in touch with you and help any way I can. Thank you for watching, and good luck.